So this was the output of our classification report. We said we had a training accuracy of 74%, a test accuracy of 76%. That's just the percentage of examples we got right in each of those data sets. Is that a good way to evaluate a classification model? In generally speaking, and I would believe in the overwhelming majority of cases, that is not a good way to evaluate a classification model. Down here we have this classification report that was done by sklearn's classification report module here, or method. And we have these precision, recall, and F1 scores calculated for all the examples that had class 0 and all the examples that have class 1. And we have how many examples were class 0, how many examples were class 1, and then we have our accuracies and our weighted averages of these. And so I want to step in right now and really kind of explain these scores in depth, and everything else will start to make sense. And so I put in a table here that just shows our precision, recall, and F1 score for class 0 and 1. And I'm going to go through what each one of these mean. So first steps first, let's first talk about what a false positive is and what a false negative is. We're dealing with binary classification, so there's only two classes we're trying to predict, good risk being class 1, bad credit risk being class 0. So our example is a lot simpler, and that's what we're going to start with. So a false positive works for both classes, but let's just say class 1. A false positive for class 1 is when the model predicts class 1, but the label is class 0. And so if the model predicts class 1, saying, hey, we got a positive, we're class 1, but the label is actually class 0, like that's the actual label, that's a false positive. And that actually works vice versa for class 0. If you imagine that a positive is actually class 0 and the model predicts class 0, but the label is actually class 1, that would be a false positive. So flipping that around, if we're dealing with class 0, if the model predicts class 0 but on an example and the label is actually class 1, that's a false positive. And it's sort of the other way around for false negative. Imagine we're dealing with all the class 1s, right? A false negative would be it saying, being a model predicting class 0 on an example, and it actually being labeled class 1. That would be a false negative. And that's the other way around if we're dealing with class 0 examples. And so from these false negatives and false positives, as well as true positives and true negatives, which hopefully you can infer what a true positive and a true negative is. Those are correctly predicted classes. From the true positive, true negatives, false positive, false negatives, these metrics, we can, or these ways of measuring accuracy, we can actually construct 3 different metrics to evaluate classification models. And they're really popular. We have precision, recall, and F1 score. So precision, if we're dealing with class 1, again, these are vice versa for every class. If we're dealing with class 1, then what that means is the precision is going to be what percentage of examples were predicted as class 1. So we're going to look at every single example that the model predicted as class 1, and we're going to see what percentage of them were actually labeled as class 1. That's what precision is. So let's look at on the test set or the training data set, whatever, on our data set. Let's pull out all the examples where the model predicted class 1. And then we're going to see what percentage of those were actually labeled as class 1. That's going to be precision. Recall is we're going to pull out all of the examples in that data set that were labeled as class 1. Not predicted, but labeled as class 1. And then we're going to see what percentage of those were predicted to be class 1. And so that's the difference between precision and recall. With precision, we're making sure that all the model's predictions of class 1, we're trying to see what percentage of the model's predictions as class 1 are actually labeled as class 1. With recall, we're seeing of all of those that were labeled as class 1, how many of those were actually predicted to be class 1. And so from these two metrics, precision and recall, we can construct an F1 score, which there's a formula for precision, there's a formula for recall, there's a formula for F1 score. You can go look it up online, but this is the intuition behind it. F1 score is the harmonic mean of the precision and recall, and you can essentially think of that as a balanced score between the two that factors both of them in. So it's going to be some sort of balanced score factoring in precision and recall. And so if you look over here at this table here, this was actually our classification report for precision and recall in F1. These were the real metrics. You can see on class 0, we had 61% precision. That means that of all of the examples that we predicted to be class 0, only 61% of them were actually labeled as class 0. And our recall was 46% for class 0. So that means of all of the examples that were actually labeled class 0, we only predicted them to be class 0 only 46% of the time. And the F1 score you can see is in between these two scores, and it's 52%. And then for class 1, it's just the opposite, right? For precision, we're going to pull out of all the examples that we predicted to be class 1, 80% of those were labeled class 1. And that's pretty good considering what we just did on class 0. And then for recall, we got 88%. That means that of all of the examples that were labeled to be class 1, we predicted 88% of those to be class 1. So even better. And then F1 scores in between those two, it's 0.84. And so that's what that means. And so the thing is why does this matter, and can we do better? So for our use case, right, we're predicting good and bad credit risk. If for our use case, we want to be really good at determining if someone is bad credit risk, right? So we're okay, right? We're okay if we accidentally. It's better if we predict someone to be bad credit risk. Our model predicts someone to be bad credit risk, but they actually wind up being good. That's just a lost customer. It's just it's unfortunate, but it happens. But we can live on. What we don't want to happen is we don't want to have a bunch of borrowers come in that are predicted to be good credit risk, come to find out they're actually bad credit risk, and they start defaulting on their loans. And so although we're good at class 1 predicting good credit risk, we really want to be good at class 0. If we could flip these two, that's ideally where we want to be at. We want to be really good at predicting bad credit risk. So let's see if we can improve that. So that is our that's precision recall F1 score, but we want to improve our performance on class 0. How do we do that? The best way that I can think of right now is to balance out the data set between classes. So what I mean by that is we have 72 examples in class 0 and 178 examples in class 1. One of the issues as to why we're so good at predicting class 1 is because the majority of the data set is class 1. Our model could just predict class 1 and do pretty good. Never predict class 0 and actually do okay. In this case, it would get 178 out of 250 right. So if your model only predicted class 1, it would get 178 out of 250 right, and that would be a decent score. But we don't want it to do that. One of the reasons why a model has a tendency to predict one class over the other, is because there's an imbalance between the number of examples from each class. So here, what I'm going to do is I'm going to use all 72 examples in my training set, but I'm only going to pull 72 examples from class 1 at random. And so I'm going to create a new training set where 72 of it is class 0 and the other 72 are randomly sampled from class 1, so that we have a balanced data set. And so here we go. This code's going to balance that data set. I'm going to use X balanced and Y balanced here to fit the model. And as you can see, our accuracy goes down, right? We were at 74.76. We're now at 71.68. It's worse. But let's look at the precision and recall on class 0, right? And so if we go back up, so let's remember our scores. We have 0.46, 0.79, and 0.58 on class 0. If we go back up, here we had 0.61, 0.46, and 0.52. So our F1 score went up to 0.58 from 0.52 on class 0. Our class 1 didn't do as well. Our precision went down on class 0, but our recall went up. So what does that mean? We're doing better on recall, a lot better. We went up from I think it was, 0.46 on recall for class 0 to 0.79 on class 0. So what does this mean? how can we interpret this? Is this better? So this means that when of all the examples that were actually labeled as class 0, we got 79% of those right. So that means that if you walk into the door and you are actually bad credit risk, our model is better at predicting you to be bad credit risk. But our precision went down, is what you're probably saying. Our precision went down. What does that mean? That means that of all of the times that we predicted someone to be bad credit risk, only 46% of the time we were right. You know, how would that be? Well, that means we're probably, well, actually, it's not probably, it's what we're doing. We're predicting more people to be bad credit risk. And so we're actually wrong a lot of those times when we predict them to be bad credit risk. But here's the thing. If they are bad credit risk, we're catching more of them because our recall went up. Remember, recall is the number of times someone actually was bad credit risk in class 0 here, and we actually predicted them to be class 0 bad credit risk. And so we improved we decreased the accuracy, but we improved the, productionability, I reckon is the word, the usability of our model in a real world scenario. And I just wanted to show you that because machine learning is not black and white. It's not, good or bad. It's not either you got good accuracy or you don't have good accuracy. Sometimes in a real production setting, this model right here that has lower test and train accuracy would actually be chosen over the other model that we used up above, just because it's better at classifying the bad credit risk. And so that's logistic regression and classification. We're going to move on to decision trees now.